a particle moves along the x-axis, which is the number line we're talking about, in meters, so that at times t greater than or equal to 0 seconds, its position is given by this function. So first is what's the velocity and what is acceleration. So velocity is dx over dt. So that's the velocity function. And what is acceleration? Acceleration is dv over dt. So this is v. We have to differentiate this to get a velocity and acceleration. Second is what is the velocity at 2 seconds and provide units of measure. So velocity at t equals 2. How can we get that? So 3, 2 squared minus 6, 2 minus 9. What is that? 12 minus 12. So that cancels out. Minus 9. Negative 9. What is the unit? So x is in meters and t is in seconds. So you see here dx, that is in meters, and dt is in seconds. So those are the units for v. And dv, unit of v is meters per second over dt, that is in s. So what is this unit? Meters per second square. Right? So for velocity, it is meters per second. C is what is the acceleration at t equals 4. So acceleration at 4 seconds. 6 times 4 minus 6. So this is 24 minus 6 is 18. And the unit is meters per second square. At what times does the particle change directions? So when will it change direction? Right? It is going this way and then it will turn around. So it is going, then it has to stop and then it turns around, right? Here velocity is positive, here it's negative, so then it has to be 0 here, right? And similarly, if it is going this way, velocity is negative and then turns around, it's positive, so here it has to be 0. For the direction to change, v equals 0 because it changes from positive to negative or negative to positive. So if you have something, this is velocity and time, right? If velocity going from positive to negative, it has to go through 0, right? Or if it is going from negative to positive, it has to go through 0, correct? Suppose you throw a ball in the air, right? It is moving up, it has to stop and then it can turn back, right? When it stops, then velocity is 0. So when does it change direction? You have to set the velocity to 0. Velocity is 3t squared minus 6t minus 9. 3t squared minus 6t minus 9 equals 0. So how can we solve this? Factor this. T minus 3 and t plus 1. Right? So if this is 0, you're multiplying these three things, right? 3, t minus 3 and t plus 1, and that is 0. That means one of these has to be 0. 3 cannot be 0. So either this is 0 or that is 0. That means t can be, so 3 and negative 1, right? But they already gave us that t is greater than or equal to 0. If t is positive, we cannot use this. That means at t equals 3, it changes direction. T equals 3 seconds. At t equals 0, is the particle moving to the right or left? So how will we find which way it is moving? So you look at the velocity, right? So velocity is positive, you're moving to the right. If velocity is negative, you're moving to the left. So because velocity positive means x is increasing, right? If x is increasing, you're going to the right. If x is decreasing, you're going to the left. At time equals 0, we have to find the velocity. So what is the velocity at 0? Velocity is this, right? 3t squared minus 6t minus 9. So what is the velocity at 0? Negative 9. So it is negative 9 meters per second, right? So which way is it going? So it is moving to the left because velocity is negative. Find the average velocity of the particle in the interval 1 to 3. How do we find average of anything? How do you find average speed? To distance traveled divided by the time elapsed, right? That is average speed. That does not care about the direction. The only difference here is average velocity is displacement, which can be positive or negative over time elapsed, time passed. So how will we find displacement? Displacement means final position minus initial position, right? So if you were here, let's say you were here and now you are here, then this is your displacement, right? So if this is say -2 and this is 7, then your displacement is -2 minus 7 is -9. It's telling you 9 units move to the left. So you can say final position x final minus x initial over time final minus time initial. This is the initial time and this is the final time, right? 1 second and 3 seconds. X at 3 seconds. Whatever is your position at 3, that is the final position. Minus, what's the initial position? X at 1. X of 3 is, we plug in 3 into this position. So 3 cubed minus 3 times 3 squared minus 9 times 3 plus 2. This 3 cubed, this is also 3 cubed, right? So this is 0 minus 27 plus 2. So negative 25 meters. And what is x of 1? 1 cubed minus 3 times 1 squared minus 9 times 1 plus 2. 1 minus 3 minus 9 plus 2. 2 plus 1, 3 minus 3 cancels, so negative 9. So this is negative 25 minus negative 9. So negative 16 over 2 is negative 8 meters per second. This is the average velocity. So on average, it was moving to the left with a speed of 8 meters per second. So in terms of velocity, it's negative 8 meters per second. Part G, what is the displacement of particle from t equals 1 to t equals 4? Displacement from t equals 1. This is just like what we did here, right? In the numerator, we had displacement. So x of 1 we just found out here. Let's find x of 4. So this is 4 cubed minus 3 times 4 squared minus 9 times 4 plus 2. So this is, so this whole thing is 16 minus 36 plus 2, negative 18. 4x4 is negative 18 minus x sub 1 is negative 9. This is negative 9. What are the units? Meters. So if the problem is using units, then in the answer you should write the units. Then H, what is the total distance of particle from t equals 1 to t equals 4? Right? Since you're moving along a straight line, your displacement and distance would be the same unless it has changed directions, right? If you're moving like this from here to here, then displacement is that and distance is the absolute value. But if you went like this and then came back here, now displacement is this, but distance will be this plus that. Displacement only looks at your initial position and final position. But distance will take, if you went forward and backward, then you travel the distance both ways. Even if you're coming back, you're traveling and you're covering distance. So we have to see if between 1 and 4, it changes direction. So we saw here, where does it change direction? At t equals 3. When we're trying to find from 1 to 4, that means from 1 to 3 and then 3 to 4. You want to find the total distance traveled, you find this distance and you find this distance and add them. And distance is nothing but the absolute value of displacement, as long as it's not changing direction. What is the distance traveled from 1 to 3? Did we find that earlier? No, so 1 to 3, we found the displacement as this, right? We have actually found out all of these. X sub 4 is negative 18. X sub 3 is negative 25. And X of 1 is negative 9. So if you think about on the number line, what is happening? It started at negative 9. This is where it started. Then it went up to negative 25, right? It came here. And then it turned around and went up to negative 18. So the distance traveled is this distance plus that distance. So what is this distance from here to here is how much? This distance is 16. And from here to here, this is 7. So when I write arrows on both sides, that means I'm not looking for a sign. I just want a positive number. It's that distance, right? So what is the total distance traveled? Total distance traveled is 16 plus 7 is 23 meters. So if you want to do without drawing this, you can do. So from here to here is negative 18 minus negative 25 and its absolute value, right? Plus negative 25 minus negative 9, its absolute value, right? So this will become 7 and this will become 16. Is the velocity increasing or decreasing at t equals 2? How will we check that? Always remember, derivative gives you the rate of change. And rate of change means how fast something is changing, which could be increasing or decreasing. So if something is increasing, then rate of change will be positive. If something's decreasing, its rate of change is negative. So if you have something going up, its rate of change is this slope of the tangent. So that's positive. If it is going down, then it is negative, right? But derivative of velocity is acceleration. So since derivative of velocity is acceleration, we just have to see if the acceleration is positive or negative. So A at 2, 6 times 2 minus 6, which is 6. And this is positive. If acceleration is positive, it means velocity is increasing at t equals 2. Acceleration is rate of change of velocity. If rate of change is positive, then that thing is increasing. And if rate of change is negative, that thing is decreasing. So now this last part is the speed increasing or decreasing at t equals 4? See, this is that thing we discussed, speeding up or slowing down. If you're speeding up, then speed is increasing. And if you're slowing down, then the speed is decreasing. And how did we check that? If the velocity and acceleration have opposite direction or opposite signs, then you are slowing down. That speed is decreasing. If velocity and acceleration are in the same direction or same sign, then they are speeding up or speed is increasing. So I need to know velocity at 4 and acceleration at 4. So did we find these earlier? Acceleration at 4 was 18 and velocity we can find out. Velocity was 3t squared minus 6t minus 9. So what is that? 15. So is it speeding up or slowing down? This is positive, right? This is positive. Speeding up because it is moving to the right and also accelerating to the right. So as velocity and acceleration at 4 have the same sign, it is speeding up or speed is increasing. Let's quickly review what we did. First, we had to find velocity and acceleration. So we found velocity by differentiating x with time, and then we found acceleration by differentiating velocity with time. And units you can just do by plugging in, instead of like wherever you see x, you put meters like this said, and for t you put seconds. Then this is dv over dt, so you took the units of velocity meters per second over the unit of time, which is second. So you got meters per second squared, right? Then we have to find velocity at 2. That means you just plug in 2 for time and velocity and find it. Remember to put the units. For acceleration, you plug in that acceleration at 4. So time equals 4. You plug that in for the acceleration and you put the right unit. When does it change direction? When it changes direction, the velocity will be 0. It has to stop before it can turn back. So you figure out where velocity is 0. So this was a quadratic. We factored it and found. And one of those we got negative when they have given us times greater than or equal to 0. So we threw away that part. That gave us that at t equals 3, it changes direction. Then this one we had to find velocity at 0 and which way is it moving. So we found that out by plugging in 0. It was negative, so it's moving to the left. Then we had to find average velocity in a given interval. So this is the time 1 to 3. So this is initial is 1 and final is 3. And average velocity is just displacement over the time elapsed. So x final minus x initial is the displacement, and time final minus time initial is the time interval. So by doing that, you can figure it out. For finding the displacement, again, it is x final minus x initial. You have to be careful with the sign. Use parentheses when you plug in negative number. Total distance traveled is, you have to see if it changes direction, then you have to split it there and add the two distances. So we see that earlier we saw that it changed direction at 3. So we have to split it at 3. 1 to 3, it was going in one direction, and then 3 to 4, it was going in the other direction. So we figured out the positions, and separately we looked at the displacements. Their absolute values are the distance traveled, and then we add them up. Is velocity increasing or decreasing? Then you just have to see the acceleration. If acceleration is positive, velocity is increasing. If acceleration is negative, velocity is decreasing. Is speed increasing or decreasing? We have to look at the signs of the velocity and acceleration. If they have the same sign, then they are speeding up. If they have opposite signs, they are slowing down.